Coming up on this week's episode of TechSNAP, the OpenZFS conference just wrapped up and Allan's back and tells us about some great new features that are coming to the file system. Researchers have found flaws in NTP, and of course we have some critical patches that you need to install. And then it's a great big batch of your questions, some rockin' answers, and a huge roundup. All that and much, much more on this week's episode of TechSNAP. Hi, everyone, and welcome to TechSNAP. This is episode 237 of Jupiter Broadcasting's weekly Systems Network and Administration podcast. We stream this episode live on October 22nd, 2015. This episode is brought to you by our three fine sponsors, DigitalOcean, Ting, and IX Systems. I'll tell you more about those sponsors as this show goes on. Our live stream, that is powered by the incredible Scale Engine over at scaleengine.com. I would personally, if I were you, go check that out. My name is Chris, and joining us every single week is our host, the admin, the tech, and the teacher. It's Mr. Allan Jude. Hey there, Allan.
Hey, Chris, everybody. Thanks for watching.
Welcome back, Allan. For those of you who don't know, Allan timed this like a ninja. He showed up like yesterday, evening you got back in town?
Late yesterday.
And not only that, but he rolled with the jet lag punches, and he is here with an outrageously great show. But on top of all of that, he was at the OpenZFS Summit, which means he's got a bunch of great experience he's going to bring. It's exclusive content right here on the TechSNAP program. So before we get into that and all of the other stories and the feedback and the roundup, I just wanted to make a special programming note that next week we'll be recording a double episode of the TechSNAP program, so we'll be starting at 11 a.m. Pacific. You can find out more.
Which is 2 p.m. Eastern, 1800 UTC.
I wasn't going to put you on the spot, but thank you.
I did the math in my head.
You can go to jupiterbroadcasting.com/calendar to have the robots do the math for you there. Two reasons I mentioned this. This is a great opportunity to get your email answered on the show. TechSNAP at jupiterbroadcasting.com or jupiterbroadcasting.com/contact is like the way most people do it because there's just a form you fill out. And that's a great opportunity because since we'll be recording 2 episodes back to back, we got to go double into the email bag. So good chance to get your email on the show. So please send those in. And also, you might consider joining us live. Since we're going to be a little bit earlier and at a different time, you could either join us for 2 recording sessions, which is a lot of fun because we do a lot of stuff in between segments. And of course, there's the setup time where we're just chilling out with the chat room. You can join us for that. But also, if you've never watched a live production, you might consider the newer live time an opportunity to join us. So jblive.tv, jupiterbroadcasting.com/calendar for all of that. So, Allan, I would normally right now ask you how the summit went, but I think we're just going to make that our top story because you got lots of good stuff. So tell me about it. Where do you want to start?
So we started the night before. We all met up, not all, a bunch of us met up at kind of a pub, but San Francisco style. So it was like they sold sausage and that was, and like you bust your own table, and it was strange, but
really?
It was cool.
Yeah, probably nothing. Really, you bust your own table?
Yeah.
Okay. All right. Do you have anything like that up in your neck of the woods?
A couple, like some of the barbecue places are kind of like that. But this was just a little strange.
All right.
But it was cool. So just a whole bunch of us sitting around talking, drinking, and eating and so on. And so that was good. And then I went back to my hotel, and we started bright and early the next day at the Children's Creativity Museum in the theater there.
Interesting.
So it was a very nice venue. They have a nice, quiet theater room with seating, like stadium-style seating, and everybody could see. They had the projector set up, and we did there. We had breakfast, and then we did that, and then we had a break. The big change they made this year over previous years is they left longer breaks so that people have more time to just talk informally and get to know people and network and so on.
I love that.
Yeah. It's, the hallway track is very important. And yes, out in the hallways, they also had tables from a bunch of the different companies that did stuff. But it started right off the beginning with the opening keynote, where Matt basically just gave us what he called metadata about how the rest of the conference is going to be and so on. But the video for that is online. And then the first presentation after that was from Nexenta, which is a company that makes a storage appliance based on OpenZFS. And they sold some success stories of people with their products, which included Hyundai, the car manufacturer, collecting data. They they're on track to generate more data per year than they have in the last 20 years put together.
And that's got to be a story that in some form or another is pervasive throughout the industries, right?
Yeah. But then they had the great one for geeky people, the new Star Wars 7 movie. All the production and CGI and all that is stored on Exciton appliances, so that's Illumos running OpenZFS.
Wow.
And they don't know how big that one's actually going to end up being yet, or
It's still in
talk
progress?
about it, or whatever.
Yeah, okay. Wow.
But well, I guess it's probably not in progress anymore because it airs in like
On
2
Christmas,
months, right?
yeah.
But the movie Gravity, which had George
Sandra
Clooney
Bullock.
and
You'd
Bullock,
say-
yeah,
yep.
that one, because it was filmed in 3D at like 72 frames per second, and they have like all the CGI, the CG source stuff, and all of that, turns out to be about 12 petabytes of data.
Whoa.
Yeah. So the movie files are huge. And if you had 12 petabytes of data, first of all, are you really going to want to use something other than ZFS? Because administratively, how are you going to manage that?
Yeah, how does that
And
even
secondly,
happen?
if it's the source for your movie, you probably kind of need to keep it around.
Data
And
integrity
so-
becomes rather important.
Exactly.
Yeah.
Also, that's a great picture. There's myself and Brian Kentrell having breakfast, I think, and then he's shaking hands with Matt Aarons.
Yeah. Yeah, there you are on the side there to the right. Yeah.
Yes, Brian Kentrell is going to be back on BSD now next month with another awesome rant. So,
Ooh. I remember the Ubuntu Kills Kittens rant.
yes. Anyway, after that, another requested session they had was Kirk McCusey gave his OpenZFS internals talk, which is kind of a slightly broader overview of how the different parts of ZFS work, so that it would make it easier for people that maybe weren't initiated on all the different parts of ZFS to understand the talks that would come after it. So he just kind of talked.
That's clever.
This is actually in a broad sense that people can just understand how the different bits of ZFS go together. And when you hear somebody talk about the MOS, this is what a meta
Right.
object set is.
Here's the
and how
common.
it works.
It's establishing a common language for everybody to share going through the conference, so that way we're all using the same words. That's really clever.
Exactly, and so you can understand the rest of it. So that was great. And then they started the presentations. Delphix presented masked ZFS send. So this basically, they have the need to replicate databases. But databases often contain sensitive information like credit card numbers or social security numbers or something. And how do you back that up when you don't necessarily trust the other side, and so on? So they come up with this way that basically they erase just the credit card numbers from the backup
Oh.
and then replicate the rest of it.
Wow.
But in a way that you can still do incremental backups.
Yeah.
And the way they showed it, as the example, they showed a picture of, I think it was the original ZFS open sourcing party. So it's a bunch of developers standing around with like bottles of alcohol. And it's like, maybe they don't want this picture to end up on Facebook. So then it goes in and replaces all of their faces with like the troll face thing or whatever, right? And then it calculates the difference, which is we can keep the whole picture, just not the faces. And then how to replicate that to the offsite and such, and then be able to keep it in sync. And because in the end, you'd rather accidentally lose the credit card numbers than have them exposed in a backup somewhere, right?
No doubt.
You can always get people to put their credit card number in again, which is much less than having to tell them that you lost their credit card number.
What I noticed, not that a lot of our listeners probably use iOS. I don't know what the stats are. Actually, I do know what the stats are. I just don't look. One of the things I noticed is when you are moving between devices or upgrading between the OS releases, one of the bits of everything gets stored in that upgrade. Like if I move between one iPhone to another iPhone and I do an encrypted backup, everything gets moved. Like the login to my Facebook, Instagram, Twitter, all of that gets moved, except Apple does not move the credit card information, which is good and bad because it means I have to re-enter the credit cards to use Apple Pay, which is whatever. I mean, I just use it as an experiment, but they technically do not have the ability to move the credit card informations between phones and between upgrades. You have to re-enter it every single time. And if you think about that on a phone, that is extremely frustrating to tap that crap out or try to take a picture of it, and then you have to go through the bank sometimes and reauthorize the credit card on the phone. Like it's this major process to go through. But it also means that the way that they store it, and this is what we talk a lot about like clear text passwords, et cetera, et cetera. The way that they store this is as images that are secured in the CPU right, as hashes. Actually, they're not even images; they're hashes secured in the CPU, and they physically cannot move that between device and device. And it's sort of, I'm looking at replacing my phone, so I'm looking at like what my different options are, and I was researching this particular problem because I have been experimenting with Apple Pay and also Google Pay, or Android Pay, and also Samsung Pay, and I've been experimenting with these different systems, and so I'm trying to figure out what is involved now when you want to move devices. And on the iOS platform, because the way they've designed it, you don't have access at all. Like the operating system literally cannot read that information. There's no way for them to move it or for them to back it up. So it's like this give and take. But what I was reading is Apple's basic opinion is they would rather lose your credit card information every single time in the backup than have to worry about storing that information for you.
Yeah. Now, if it was encrypted and you could like move the key, maybe, but
that was actually what I expected to happen. I thought, okay, well, they would encrypt the backup because they have something called encrypted backup. So you would encrypt the backup to a master phrase, right? And then you would think you would be able to recover that. But they store the credit card information in the actual CPU itself, not in the file system of the operating system.
Right. Cool. And then the second presentation from Delphix for that. Some of the presentations were awfully short because there were so many to go through. But the other one was ZFS send compression. So currently, when you do ZFS replication, it's actually decompressing any compressed blocks to send them over the network and then recompressing them at the other side.
Oh.
Which is kind of a waste.
Yeah.
Part of that was originally because you don't know if the other side has compression or if it even supports LZ4 and so on. But now there's basically a flag that says, don't do that, keep it compressed. And that can speed up things quite a bit.
No doubt.
And avoid having to do, ZFS send, pipe gzip, pipe SSH, blah, 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 and then unzip it, and then pipe it into ZFS receive. And so that'll be nice to have.
Yeah. Boy, that seems like it could be a major change.
Mm-hmm. And then OVH, a big hosting company in France and Canada, demonstrated something they built called zMotion. Which is a way to basically migrate ZFS shares from one machine to another live. So it basically takes care of the step of take a snapshot, replicate it to the other machine. When that's done, take another snapshot and replicate that, and keep doing that until the delta between the snapshots is down to like less than a couple seconds, and then switch the IP addresses. But they also had to deal with the fact that...
Did they? Maybe they didn't say. I'm sorry to interrupt. But how does the file system change an IP address? How does this file system communicate to the operating system?
zMotion's a tool that runs.
Oh, so zMotion is sort of an orchestrator that does all of this. I see.
Yeah.
Okay.
And then the complication they had was that the unique ID number of that file system on the second machine would be different.
Mm-hmm.
And so they had to build a mechanism into ZFS for you allowed to basically use the persistent GUID that is always going to be the same for those, so that the NFS client that's connected doesn't actually know that it's now getting it from a different server.
Mm-hmm. Right. Yeah, it would be completely oblivious to it if the
because otherwise
GUID stays the same.
Yeah, if the ID the FS ID number changes, the NFS client freaks out.
Right. And hangs and does all kinds of unreliable
the one on
things.
Linux is especially bad, yeah.
Yeah.
And they were talking about that. And it was like, so after 3 attempts of different ways to solve this problem, they actually came up with one that works, and they're using it.
So how do you synchronize the GUID between the machines?
They basically expose it as a ZFS property, and you can just set it.
Oh, so you determine it. You just say, this is going to be this GUID.
Well, in particular, the zMotion script will just copy the ID from the source to the destination.
Oh, that is slick.
Mm-hmm. So that was cool. Then we got story time. Everybody loves story time.
Yeah.
So Jeff Bonwick came and presented, who's the guy that started ZFS, presented the birth of ZFS and told the story of how, they tried to get started and it didn't really work out. And it was like, the 5th time Sun had tried to write a new file system and it was doomed. From the beginning,
I thought it was
80 people trying to work at it.
I honestly thought it was. When I heard Sun's working on yet another file system, I thought, oh, good.
I didn't even hear it back then. But they gave him a team of like 80 people, and it just wasn't working. And then at one point, Matt Aarons showed up as a student, fresh out of school or whatever, and he interviewed with Jeff, and Jeff promised that they were going to build a file system. And so then when it came up to the point where it wasn't working, and Jeff's like, well, we can't not do this because I promised Matt that we were going to do this. So they started fresh with just the two of them, and they actually managed to do it. And then they brought in more people after that.
There is a lesson.
There's lots of people. But
there is a lesson in that.
Yeah.
There is a big lesson in how actual software gets created in that.
Right. And the big one was about developer buy-in. The problem with when you got the team of 80 people is that these weren't 80 people coming to start working on this project. These are 80 people that were working on stuff already and weren't necessarily even interested in doing what he was doing, right? And so, yeah, he tells a great story about that, and it's a good way to, if you're working in an established company where you have all these people that are already kind of in the middle of stuff, it's great to understand what it requires to get people to buy into this idea and actually push it forward. And once they do, the results can be amazing.
Yeah.
But yeah, he told lots of cool stories about how ZFS got started, and also explained this. I wasn't going to share this, but since we have the video, it's in there. But I was going to keep it for the book. But if you've ever looked at any of the ZFS documentation and you saw that the default pool name is tank in all the documentation,
yeah,
and everybody just thought it was, tank just meant, because it's like a storage pool,
storage
right?
tank.
Tank. You put
storage tank.
Or because ZFS is strong, like an armored tank, and you can't, right? It turns out no. They named the various test machines and so on in their and the pools in their lab after characters from the Matrix. So there's actually Tank and Dozer.
Yes.
And Zion and so on. And
that's amazing.
It just happened to be the one that was used in the documentation happened to be Tank.
That's amazing.
So it could have just as easily been Dozer. And then people maybe would have thought...
How did that come up, Allan? How did that come up?
Somebody asked.
Yes, that was in the Q&A. Is that where that?
Oh no, I think it was in the story.
That is
questions there too.
That is great. That is I love it.
Yeah. Then they had a talk about declustered RAID, and the basic idea here was when a drive fails, rather than replacing that drive and writing basically all the data back to that one drive. The problem there being that you're limited by the speed of that drive, right? If you have a 12-drive array and one drive dies and you replace it, you have 11 drives reading and one drive writing, and that one drive is not going to be able to write as fast as the other 11 drives can read. Mm-hmm. But with this declustered RAID, basically you would write some of the resilver data to the other existing good drives and get your pool back to a working state much quicker. But if you want the details, there's a whole half-hour video on it.
Yeah.
But it's really cool.
Yeah, it is.
Then there was a student who worked at Delphix as an intern, gave a talk on his project Eager Zero. So this is for thin provision storage like AWS or VMware. And basically, they've shown there that they allocate the space in the backing device as you use it, right? Kind of just like in a normal VM or in AWS, right? But that means that the first time you touch a block, it's going to take longer than normal to write to that block or read from it. Well, you wouldn't read from it because you've never written to it. But you can lose up to 50% of your IOPS because you have to wait for that sector to actually be allocated by the backing storage somewhere. And so that basically leaves you in two positions. Or you have three options. You can just suck it up, and the first time you write to every sector, it'll take a lot longer than usual. You can make the deployment of the machine take a lot longer by writing zeros to the whole hard drive before you start. But that could take hours and hours or longer. Or you have this Eager Zero option, which basically gets the machine up and running right away, but in the background at low priority is writing out all the unused space with zeros. And then, maybe during the beginning, some places you go to write are not going to have been initialized yet, but most of the time you're going to end up getting better speed, but it's not going to block the creation of your virtual machine for hours while you wait for it to happen.
Right.
Plus, there's a minor enhancement to this. You could actually make ZFS preference to allocate space from the places that have already been zeroed to further reduce the possibility of the slowness. So that was cool. And then we had lunch. Lunch was good.
Oh. And there was ZFS Cake.
That was later. We'll get to that.
Oh, okay. Okay.
Then George Wilson presented his work on a compressed ARC. So ARC is the adaptive replacement cache. This is the part of ZFS that makes it really, really fast. Is using all of the RAM that you will give it to cache the blocks that you're using most often, most frequently, or most recently. And
the blocks.
part of so the blocks of files.
Yeah.
So that's if you're only using part of a file, it'll only keep the part that you're using and not push other stuff.
That's what I was thinking. Yeah.
Yeah. So the interesting thing is we've added compression to ZFS, especially LZ4, which is really, really fast. But if you read a compressed block, we decompress it and then cache it.
Okay.
But
that
what
makes
if we
sense.
cache the compressed version? Since we can decompress the blocks at gigabytes per second with LZ4 because it's so fast, if we leave the block compressed in RAM, we could fit that much more stuff in the ARC.
Yeah, absolutely.
Especially if it's like a database, which is what Delphix does with ZFS, where you're getting between 2 and 5 times compression. That would basically mean you now get between 2 and 5 times as much RAM. Almost.
That's genius, and it's kind of obvious too.
Yeah. So with their test workload of a real customer's data, they were fitting 1.2 terabytes of blocks in RAM and only using 470 gigabytes of the 768 gigabytes of RAM in the machine.
Wow. That's a huge...
Because it was like a 2.7 to 1
Very
compression ratio
nice.
or something.
Very nice.
Yeah. And so then each time you read the block, it gets decompressed and then sent. Although they actually keep a buffer of uncompressed versions of blocks. So if you're reading a block a whole bunch of times really quickly, it won't have to decompress it every time.
Yeah, okay. So it's kind of smart.
Yeah, and that buffer is tunable, but I think the default's like 100 megabytes. So they don't expect it to need to be very large because it's usually not CPU bottlenecked, right? LZ4 is so fast. And so that one is something everybody's looking forward to because, that will let you get that much more out of ZFS without
that's one of
the
those
existing amount of RAM you already have.
Well, that's one of those features where it's like by using, I mean, just if this was a company and they were going to promote something by using your existing hardware and your existing setup, you're going to get X more. It's without having to invest in any more hardware. That's a big deal.
Exactly. Sadly, it won't help me very much because video doesn't compress.
Yes, or MP3s, right? Or
right, yes.
or probably like most like RPM files, anything that's stored on Scale Engine.
Yes. But the interesting thing is that the compressed ZFS replication work actually depends on this compressed ARC work because it's the blocks go through the ARC. But anyway, that's cool.
That makes sense.
Then somebody gave a talk on discontiguous caching with ABD. This one was particularly targeted at Linux, but is actually being ported to Illumos as well. Especially under Linux because of the way the memory allocator works, and they're currently using the slab allocator because they have to allocate like big 128Ks of memory at a time.
Nice.
And getting a contiguous amount of memory can be problematic, right? If you allocate and deallocate a lot, you end up with fragmentation. And it turns out there's nowhere left in your RAM that actually has that many blocks in a row that are available. And so ABD uses like a scatter-gather to basically make up a block by gathering a bunch of small pieces and solving that problem. Yeah. So
does BSD not suffer from this memory?
I think it already has
fragmentation?
something similar.
Because they've been that makes sense. It's been in production for a while.
Yeah. Well, even Illumos has had this problem, and the big thing is that this is only going to get worse as we've upped the largest block size you can have moved from 128 to 1 megabyte and is on its way to 16 megabytes.
Sure.
And so obviously that means that we have to be able to allocate memory and probably don't want to rely on being able to do 60 megabyte contiguous chunks at a time.
Yeah, that makes sense.
So that's interesting work there. Then Sasso, who's the guy that actually did the LZ4 implementation, gave 3 talks really, really quickly. The first one was about scaling deduplication. So the problem with deduplication on ZFS is once you start deduping data, even if you turn it off, the data is still deduped, so you have to keep this table around that tells you where the blocks are. And if that table doesn't fit in your RAM, it gets really slow. And in particular, basically, it'll work okay until one day when it just doesn't. And then it'll be so slow and you can't fix it.
No good.
So he introduced the idea of a dedupe ceiling or a dedupe throttle. And basically, combined with other work that would basically, instead of keeping the DDT in RAM, you would be able to say, this SSD is dedicated to only holding the DDT, the dedupe cable. And then this work would basically put a throttle or a ceiling in that would say, once that SSD is full, stop deduping and just write the stuff undeduped, because until we can add another SSD or something to hold a bigger dedupe cable. Because the other option is your system gets so slow it's unusable. Right?
Not ideal.
Yeah. Now, to go with that, you then he also presented work on a persistent L2 arc. So L2 arc is basically, the arc is what you can fit in RAM, and then you have a level 2, which is normally an SSD or an NVMe or like a RAM card or something. And what those do is when data won't fit in the arc anymore, like when it's aged out of the arc where we need to delete it out of the memory to fit something newer in, instead we're going to put it on this SSD, and that will give us that much more cache that's still faster than going to the spinning hard drive.
Yeah, of course.
The problem with the L2 arc is that when you reboot, it starts empty every time. So he's presented work where basically it keeps a record of what's in there, and when it boots up, you'll be able to just go through and do that.
So it's like a journal?
Yeah, except he made it so that it doesn't block ZFS import. So the system will actually boot up and come up normally, and then in the background start reloading all the stuff that's on the L2 arc and adding the references back to your RAM so that you can start using it. That way, it doesn't actually slow down booting up, especially if you have, some people have like 4+ SSDs full of L2 arc, terabytes of L2 arc. But that'll be really interesting work, especially, at first when I saw somebody mirroring their L2 arc, I was like, why would you do that? If you stripe them, you get twice as much cache this way. And, if you lose one, it's only the cache. The original file is still over there. And they're like, well, it turns out that our app needs an L2 arc. If we actually have to go to the hard drive, it's too slow. So if one of our SSDs dies, we actually mirror them so that we can keep up the level of speed we need. And so I can see them also needing the L2 arc. Otherwise, if they reboot, they have to leave the machine, offline for a while to let it warm back up.
Yeah, right.
So that'll be really interesting. Although, because of the way it works, it probably won't help what Chris Moore wanted it for, which was, kind of like a prefetch when booting to make your system boot faster.
Yeah, of course.
Because it's not going to, you definitely don't want it to not finish importing ZFS until it's read through the whole L2 arc, because that would actually make booting take even longer. But because it's doing it in the background, you're probably not going to have loaded much of the L2 arc into RAM or back into usability before your system's finished booting anyway.
That seems reasonable.
But it is interesting work. And then lastly, he presented on ZFS native trim. So there's been trim support for ZFS built into FreeBSD for a while, but it's very specific to FreeBSD. And Illumos and Linux still need a solution for this. So he's building a better one, and it is better. So FreeBSD will adopt it as well.
So it's what is different? So is it not implemented at the file system layer right now?
Right. In FreeBSD, once a block is going to be freed, we just pass it down to our geom storage layer that then will trim it.
Okay.
And so this one is a little smarter about it as well. It'll do bigger chunks at a time, but in general, it implements the same strategy, which is when a block gets freed and we're done with it, it goes on a list. And then only after something like 64 transaction groups do we actually send the trim command. In case we reuse that block in the meantime and we didn't need to bother trimming it. Right? Because if trimming it is extra work for the SSD and it wears out the flash faster.
True enough.
So this allows you to basically, only once you're sure that you're not going to need that block again for a while, do you tell the SSD to trim it.
Wow. That is nice.
And it also has a throttle. It only trims so many blocks at a time as each transaction group goes forward. So you don't often if you trim a whole lot of blocks at once with an SSD, the SSD will kind of go catatonic until it finishes the work.
Yeah.
It'll block other things from happening, and you really don't want that to happen,
No.
right? So you meter out the work over time so that the SSD performs better. And you can see he's got a timeline graph of how that works there. Then the next presentation was about sandboxing ZFS on Linux. So on Solaris, or like Illumos, and on BSD, we have zones and jails. And basically, those are container frameworks. And we have a way to say, take this data set and give it to root in this jail, and they can do whatever they want with it. And they kind of want something like that for Linux. So this is talk explaining how the work he's done so far to get it to work, but also what the current limitations and drawbacks are of the container frameworks on Linux. And
what are they? What are they?
They have no way. The code for ZFS on Linux just assumes that root means root, and basically it doesn't have a way to limit what things root in the container can do versus what things root on the host can do, like FreeBSD and Illumos have. And currently, the way you actually sandbox a data set is by like echoing some stuff into like /proc and so on, instead of using the ZFS command line.
So in other words,
I guess the other big problem is that unlike on Solaris and BSD, when you create a container or a namespace, a namespace on Linux, it doesn't have its own unique identifier, right? Like on FreeBSD, you have a jail that has a name and a number. And I think Solaris zones are very similar. But on Linux, when you create this container, it's just like this process is in a container. It doesn't actually have an identifier where you could say, give this ZFS data set to this container.
Each process it's done at the process, right? Each process has its own namespace, essentially.
But you can have multiple processes in the same namespace, but the namespace itself doesn't actually have an ID.
Yeah.
And so how do you give a ZFS data set to it?
Seems like they just need to add an ID.
It's a bit more complicated than that, but yes, there are some missing pieces in Linux to be able to implement the same behavior, but there are people working on it. And then next we had a presentation from Intel, actually, about metadata allocation classes. So this is extending that idea of putting the dedupe table from the onto an SSD, and taking it further, and saying for each different type of allocation, we could have classes with different dedicated VDEVs. So we say, let's put all of this type of metadata on this SSD, all of this type of metadata on that SSD, all the dedupe on this, and all the slog on this.
Okay.
And then if any of those get full, just fall back to doing it the normal way. But basically saying, how about we put all the metadata for our files on an SSD, but leave the actual data for the files on the spinning hard drives, right? And things like that.
Yeah.
So that can be really cool. And it allows us to do things like having the dedicated SSD for dedupe and other interesting things like that.
Well, and you can also say, it looks like from this, you could say, this SSD is going to use a block size of this size, and we're going to have sizes of this size for this SSD, which
it was more, so when you're writing to your physical disk, if you're using what's going to be the largest block size on ZFS of 16 megabytes, you're going to be blocking down these big chunks of 16 megabytes on the disk.
Yeah.
But after you write that 16 megabytes, you have to write the metadata for it, which is 4 kilobytes.
Right.
And if you leave a little 4 kilobyte there, then the next 16 megabyte chunk isn't lining up in a nice spot, is it?
Yeah, that makes sense.
And you end up with them all like offset weird, and then you free that, and then you have this little 4K bit of fragment over here. And so by just allocating the metadata in a different place, whether it's maybe on the same drive but in a different offset or on an SSD, you deal with the fact that there's really a lot of different tuning that goes on between writing a giant 16 megabyte chunk and writing a single 4 kilobyte chunk. And if you have to do a lot of these 4K chunks, you're going to get better performance from an SSD, whereas if you're writing big 16 megabyte chunks, you can get really good performance out of a spinning disk even. So that was interesting. And then especially for people that are maybe a bit newer to ZFS, he wrote ZTour, which is a Fuse implementation of ZFS, not of ZFS, of ZDB, the debugging tool for ZFS. So basically it creates this Fuse file system that lets you walk through the metadata of ZFS as if it was a set of directories. So like you see an object by its number and you open it up, and then each of its subfields is another directory that contains all this information.
Cool.
You did a little video tour of it in the video, but basically it allows you to see inside the ZFS metadata in a much more graphical way, or even from the command line even. But in his example, he was using the file browser in whatever operating system he was using, and kind of just see what is actually happening inside ZFS. And I thought that was really cool.
So it's called Z-Tour. So if you jump around, you'll probably find it in the...
Yeah, you just basically had to take a tour of the metadata of a ZFS file system.
Cool. That is really cool.
Yeah. And then there was a talk about write-back caching and improving performance on ZFS, which was really cool. And then they did a story time and question and answer session with Matt and Jeff as part of the closing, which was, just asking them a bunch of questions about the invention of ZFS and did they think it would be this popular and, all that kind of
That's cool.
Interesting stuff. About, one of the interesting that came out of that was a discussion of certain design decisions they made at the time. One of them that actually came up in the FreeBSD chat room this morning was that the minimum size of a disk you can use in ZFS is 64 megabytes. Right? They did this because you can create backing disks that are just a file in like /temp for testing, and that's really cool. But it turns out that meant they had to be very accurate with their accounting code for like where space was being used and so on. And they really wish they had just made it be like 10 gigabytes, so they could have been less exact with the rounding code. Because that's especially becoming an issue now that they never envisioned people doing 16 megabyte blocks. If your block size is 16 megabytes, your 64 megabyte disk isn't going to last very long.
No.
And so, yeah, there was a lot of interesting things about that.
That sounds like it was a good event, Allan.
That was just the first day.
What? Are you kidding me?
Nope.
How was the second day?
I said, some of those presentations were only given 15 minutes to fit all this stuff in.
Wow.
So the second day, we did something completely different. We went to GitHub's office in San Francisco and sat in their lunchroom and had a hackathon. So basically, you got to work with people you maybe just met or only ever got to work with online or whatever, but worked with a bunch of people to do different projects. So they had a bunch of different ideas for everything from little things to big things that we want to change in ZFS, and it was write as much of a prototype as you can in one day, and we'll all present our work at the end, and there's a link here to the video presentations of that. And then we voted and picked the best projects, and they won prizes donated by Nexenta. They were those that soccer ball droid from the Star Wars movie.
Oh, cool. I don't know what its name is, but that's very cool.
I forget its name too. I'm not a Star Wars person.
Yeah, neither am I.
But
I mean, I like Star Wars. Don't get upset, everybody. Star Wars is great, and the new trailer is really cool.
Star Wars is terrible. Star Trek forever.
Wow.
Anyway, so lots of different projects, including that metadata classes thing we talked about. The original presentation was just for doing it for metadata, but after seeing other presentations that were, it turned out there are 3 different companies working on something similar to that. He built a more generic one that did 4 different classes. And so he actually has a working demo of that he showed us in the presentation part. There was also work to do a new compression algorithm, LZ4HC, which basically takes longer to compress. But so the decompression code is the same, so you get the same decompression speed, but you can spend more time while you're compressing and get a smaller size out of it. So while it took 6 seconds to compress this data with LZ4, and you got a 2.1x compression. If you compress it with LZHC, it took 26 seconds, but you got 2.7% or whatever. And then, but when you decompress, you always get the same original speed. So
that's
you
nice.
Can opt to say,
that's very nice.
This is data I'm not going to be writing very often, and it's very compressible, or I really need the space or whatever, and get higher compression, but still get the really high decompression speed you would get from LZ4. And if I'm not mistaken, it also still has the early abort code so that if it turns out it doesn't compress very well, it will just not bother instead of spending all day on it like gzip would.
Nice. That's smart. Good. As somebody who works with a lot of stuff that's already comes compressed.
Or is uncompressible, then yes.
Yes. That's very nice.
And then I forget what one of the other winning ones was. You'd have to watch the video. And then I worked on a project during the hackathon. One of the original ones I was going to do was JSON output from ZFS. But it turns out someone's already finished that.
Oh, good. Nice.
It's still being reviewed and needs a little bit more work, but it is done, so I didn't work on that. I worked on a new subcommand for ZFS that will be, I think it's going to end up being called ZFS ABI or API. And basically, when you run it, it outputs a list of the changes to the ZFS command line interfaces. So that, for example, I have this script called ZXFR that does the replication of data for Scale Engine. And it's up on GitHub. And a problem I had when I was writing it was that some of my boxes were running FreeBSD 9.0, which has ZFS version 28, and some of them were running FreeBSD 9.1, which had ZFS version 28, but had a bunch of improvements to the command line interface that made it better. For example, the no-op flag that would let you estimate how big an incremental replication was going to be, so you could draw a progress bar to tell how far, so you could figure out ahead of time this is going to be 5 gigabytes of data. So that way when you're doing the replication, I've done 4 gigabytes. Do I have 1 gigabyte to go or 100? Right? And normally it'd be like waiting until it was done to find out how big it was.
Yeah.
So this way you get a progress bar and a time estimate and all that. But because it didn't change anything about ZFS itself, it didn't bump the version number, right? And so there was no way to track that existed. So it was very difficult to tell. And then now with, the fact that you can use ZFS on so many different platforms now, right? It's like Solaris and Illumos and the derivatives of Illumos like SmartOS and OmniOS and so on. And then you have Linux, and especially with different versions being everywhere, you can't just necessarily look at the operating system version to tell you what's there, right? Because Illumos itself doesn't actually have release numbers. And if I'm running FreeBSD current to get the new features, then how do I tell? FreeBSD 11 didn't have that feature, but now it does because it's not actually released yet, and so on. So it gets really complicated. So this will basically give you something kind of like feature flags in ZFS, but for changes to the command line interface. So my script will be able to tell that, this target machine supports being able to set more than one parameter at a time with ZFS set, and it's a lot faster if you do it that way. So when I'm copying the parameters or the properties of one data set to another, I can do one really long ZFS set command instead of 30 separate short ones. And it'll be a lot faster. But if that machine over there is an older version of FreeBSD that doesn't support that feature, then I can fall back to doing it the slow way. So that's what I worked on. And hopefully that will be upstreamed.
What is the setup like? Or do you bring your laptop in there and
Yeah.
Okay, that's cool.
Yeah. So GitHub just provided really fast Wi-Fi and in space, and then we brought our own people and food. I guess GitHub provided power.
Oh, that's nice too.
But yeah, we just organized catering and we just basically sat around at big tables on benches and did this. And they had some nice spaces though. There's like these chairs look like the ones from the Men in Black, the first one where you had to sit in the thing and write the exam.
Yeah.
And they were like an egg or something like that.
Yeah.
A bunch of interesting things like that.
All right, Allan. All right, but now what about the cake?
Oh yes. We had a dinner after the presentation day, at the end of Monday, and they had a cake because October 31st will be the 10th anniversary of the open sourcing of ZFS.
Oh, it's a little celebration cake.
Yes.
Nice, very nice. Well,
It
Allan.
was very good.
Well, Allan, sounds like it was a pretty good trip.
It was.
So, would you go again next year? Are they they're doing it again?
Yep. I will possibly even try to make it to the one they have in Europe as well.
Good man. All right. Well, cool. Any other thoughts on this story? Quote unquote story.
I'm sure I missed some stuff, but lots of good stuff happened. It was great to meet a bunch of new people.
Yeah. That does sound like a good one.
And I've got a bunch of new people to interview, so that's good.
Ooh, also very good. All right, well, everybody go check out DigitalOcean, sponsor of the TechSNAP program. SnapOcean is the promo code you use to get a $10 credit, and DigitalOcean is a simple cloud hosting provider dedicated to offering the most intuitive and easy way for you to spin up your own system up in the cloud. DigitalOcean has a great infrastructure that's all SSDs, and they have data centers in New York, San Francisco, Singapore, Amsterdam, London, Germany, and a brand new one in Toronto. So you can pick from any of these data centers. You can pick from any of them, and they, in some of their latest ones, have really, really, really done some impressive work. In fact, if you go check out their Instagram and their Google Plus accounts, you can see some of the pictures. But like, for example, 40 gigabit E connections to each hypervisor. Their fastest SSDs ever in these things. And it all comes together on the DigitalOcean interface that makes it really fast, really simple, and straightforward to deploy your own DigitalOcean droplet. Think of a droplet as your own machine on demand. You can just deploy it right now in 55 seconds, and pricing plans start only $5 a month. That'll get you 512 megabytes of RAM, a 20 gigabyte SSD, one CPU, and a terabyte of transfer. A terabyte of transfer, which is redonkulous. And their interface to manage all of this is so great. You can deploy applications with one click, and the pricing is so nice. You can, if you go to DigitalOcean.com, right on the front page, scroll down a little bit, straightforward. $5 droplet, $10 droplet, $20 droplet, etc. You go from there. It's really nice, and each time you get a nice upgrade, and you just kind of think about, what's my workload? What kind of resources do I need, and which droplet makes sense? And I would encourage you to try out the $5 droplet and see how that goes. And DigitalOcean's also introducing floating IPs, which is really nice. Make it much simpler to move between systems. You and I were talking about this on the pre-show, Alan. What's kind of like the concise way to explain what a floating IP is? Because I could go on and on.
Yeah, so normally when you start up a droplet, it just gets assigned automatically an IP address from DigitalOcean.
Right.
But what if you're running your app on that, and now you want to upgrade? Right, you're going to deploy a newer version of the OS or a different OS, and then a newer version of your application or whatever. You could snapshot your running machine, clone it, bring it up over here, do all your upgrades on it, get it working, and then now you want to run your website off the new droplet, but all your traffic is going to this old IP.
Yeah.
You can try to change the DNS entry, but that could take 24 hours or more, right? So instead, with these floating IP addresses, you can just take the IP address from the one droplet and move it to the other, anywhere, as long as they're in the same data center. And so you can actually also set this up for high availability. So it can happen automatically. If one of your droplets goes down, the IP address that's serving your website will just move to your other droplet.
Love it. I love it.
Yes.
Yeah, check it out over at DigitalOcean.com. Remember, we have the promo code SnapOcean. That'll give you a $10 credit. You can try it out 2 months for free. Go play with their interface, try their different pricing structures, see what works best for you, and go deploy a few applications and see the difference. And it's really nice, too, if you are working with containers. They got FreeBSD and Linux, and what's really, really great about that is you can start developing locally on your system and then just push it right up to DigitalOcean when you're ready to go online. DigitalOcean.com, use the promo code SnapOcean, one word, lowercase. And a big thanks to DigitalOcean for sponsoring the TechSNAP program. And also, I'll just make a note, too. I personally just spun up another DigitalOcean droplet this last weekend with a combination of GPG and SyncThing and Pass. And I'm rolling my own password management solution to replace LastPass. And DigitalOcean is where I'm hosting sort of the online version of that. So I have access to this. So, Allan, I've been reading a lot about these stories regarding NTP and new attacks against NTP. And, of course, we've talked about the NTP amplification attack in the past. So this week, I saw you have a story in here about essentially another NTP story. What's going on?
Yes. So starting at the beginning, if you don't know what NTP is, it's one of the oldest protocols still in use on the internet. It is the network time protocol. It's basically a way for your computer to go ask a computer that knows better, what time is it? And basically, NTP has a hierarchy where at the top are machines that are actually connected to an atomic clock and know exactly what time it is. But those machines, there's only so many of those machines because there's only so many nuclear clocks. So we don't ask them directly what time it is. They tell
they get overwhelmed, you might say.
So they tell the next layer, and then that layer goes and tells ones at ISPs or the one at Microsoft and so on, and the ones at universities what time it is, and then we ask them, right? It basically filters down. But yeah, your computer pings it every once in a while. Depending on your client, it can be fairly frequently, and says, hey, what time is it? And then adjust your clock to make up for the fact your clock might be running slightly fast or slightly slow, because the clock chips built into computers are not perfect. The other thing is that the reason we do this is because a lot of original computers didn't have a way to keep track of time, and I think like Raspberry Pi doesn't actually have a clock chip. So you have to tell it what time it is when you start it up, otherwise it doesn't know.
Well, and a lot of systems, a lot of communication between systems requires that they're talking at the same time. So like, for example, Active Directory on Windows and Kerberos very much require that pretty much all the machines think it's exactly the same time. And if that drifts too much, then authentication begins to fail.
Exactly. Like, I think, so most of those have a window of like 10 seconds or something. And if you're outside of that, then things break. So yeah, it's very important for many applications, actually, especially cryptography, right? If your clock is wrong, then how do you verify a certificate that says it's only valid between this date and this date? If your clock is wrong, you might think it's still last year and it's not anymore, right? That certificate's expired. Or, one-time password type systems. If the password you have is only good for 60 seconds, but you generate it based on a clock that's wrong, you generated one for 4 hours ago, which isn't going to be accepted because it's not for the right time. So the importance of NTP was highlighted back in 2012 when there was an incident in which two servers run by the U.S. Navy rolled back their clock by 12 years and then decided that it was the year 2000. Computers that checked in with the Navy service and adjusted their clocks accordingly had a variety of problems with phone systems, routers, authentication systems, and all kinds of stuff. So, researchers at Boston University announced yesterday that it's possible for an attacker to cause your organization's servers to stop checking the time altogether. So it turns out in the NTP protocol, there's a feature called the kiss of death. And basically, it's a way for a server to tell a client to stop pestering me. It was designed for a client that's broken is like asking for the time like 100 times a second or something. And it says, NTP has a rate limiting mechanism nicknamed the kiss of death packet that will stop a computer from repeatedly querying the time in case of a technical problem. When that packet is sent, the system may stop querying the time for days or even years, according to a summary of the research. I'm not sure what makes the difference in days and years. It might be the version or how many packets you send or something.
Or the default config is or whatever.
Yeah. So the researchers have posted a website about it and their PDF. But basically, they could spoof being the time server and send you this kiss of death packet, and you would stop talking to the time server for some amount of time. And then your clock would drift and be incorrect. So they outlined actually 4 different attacks against the NTP protocol. The first is called the denial of service by spoof kiss of death. And basically, they show an attack that basically you can deactivate the NTP client on most computers on the internet using just a single attacking machine. By being an off-path attacker, which meaning not having to be man in the middle, you're just over here at the side, located anywhere on the internet, you can exploit the TCP rate limiting mechanism, the kiss of death packet, and basically spoof being the real time server they're trying to talk to and say, hey, stop pestering me. And then the client will stop checking what time it is. Hopefully the client maybe talks to more than one server, but I can just pretend to be, the 100 most popular servers and send 100 packets to each person, and all of a sudden it's over, right? They specifically mention here, because the attacker only needs to send a few kiss of death packets per victim, standard networking tools like Nmap or Zmap can be adapted very quickly to launch this attack in bulk against every client that's listening on the internet.
Right. That makes sense.
Yeah. So this vulnerability has been classified CVE 2015-7704. Then the second attack is the denial of service by priming the pump. Even if the vulnerability that allowed kiss of death packets to be trivially spoofed is patched, an off-path attacker can still disable NTP at a victim client. This attack once again exploits rate limiting via the KOD packet. Here, the attacker elicits a valid kiss of death packet from the client's pre-configured servers by priming the pump, i.e. sending the server a high volume of queries that are spoofed to look like they're from the client. So basically, instead of spoofing being the server and telling the client to shut up, you spoof being the client and annoy the server until it's one packet away from saying shut up, And then the client sends that final real one saying, hey, what time it is? And they're like, shut up. Right? So turns out this one can be done from either side. Next, attack number 3 is time shifting by reboot. We discussed how an on-path attacker that hijacked traffic to an NTP server using BGP or DNS or something can shift time on a server's clients. Under normal conditions, if NTP attempts to update the local clock by a value that exceeds the panic threshold, which defaults to about 16 minutes, then the NTP client should exit with a diagnostic message to the system log. We discussed how to circumvent the panic threshold by exploiting NTPD's behavior upon reboot. Normally, when you first boot up, the NTP thing doesn't have that limit in case your clock is actually just really wrong, right? Especially on servers that stay on a lot, the CMOS battery tends to die because it doesn't normally get discharged and recharged like a machine that actually gets, like an office machine that's on 8 hours a day and then off.
Actually then uses the battery.
The battery lasts a longer, and then sometimes in a server where they're never off, the battery just is, because it's constantly being trickle charged, it just dies. Right? It's kind of like they need a retensoring.
Yeah, it doesn't get exercised, basically.
Yeah. So they present a small step-by-step or small step, big step attack, which allows an attacker that reboots the client to stealthily create a big time step and then quickly bring the client's clock back to normal. This attack is useful for stealthily flushing a client's caches or to cause a specific cryptographic object to expire. Some small step, big step attacks are actually described in a CVE that they had issued or in part 4B of their paper. But basically, you could step the time to be really wrong, and then they won't accept some SSL certificate during startup or whatever, and then you step the time back to normal, and nobody will know that anything is wrong. And then lastly, they have attack number 4, which is time shifting by fragmentation. So they show how an off path. That's really hard to say.
Yeah, it's odd. It's an odd combo of words.
Yes, attacker can exploit IPv4 fragmentation to shift the time on a client. We explain why NTP's clock discipline algorithm require our attack to craft a stream of self-consistent packets rather than just one packet, and demonstrate its feasibility for proof of concept implementation. This attack depends on IPv4 fragmentation policies at the client and server OS rather than on weaknesses in NTPD itself. So that might actually be a problem in operating systems, allowing really small packets or something like that. I think it was like 68 bytes or something, which is interesting. So they then talk about what you should do for each of those ones. If for attack number 1 and 2, if you upgrade to the latest NTPD, then that helps a lot. And you also have to monitor your system log for error messages like received unexpected origin timestamp from somewhere. For the time shifting by reboot, you need to monitor your system logs for suspicious panic events or restarts of NTPD. Alternatively, if you run NTPD without the -G option, it won't panic, and then you won't have your NTPD get shut down. For the fragmentation one, this one kind of runs on any OS that accepts path MTU discovery requests to fragments down to 68-byte MTUs. So if you're running an NTP server, they have a set of advice for you. They have a minimum PMTU on Linux, which I think is, as long as it's set to 90 or more, then it should be fine. And they go on to talk about that. And basically, their network measurements indicate that servers running SunOS or Linux 2.2.13 are especially vulnerable. Hopefully there's not that many of them. But with the embedded stuff, there's a bunch of those out there.
Yeah, I guess when you look embedded, that's true. Yeah.
And then if you're a client, check if your client is taking time from vulnerable servers, and they have a little tool to test if a server is vulnerable. Log into your client, type NTPQ, and then check the peers and so on. And if your servers are vulnerable, then replace it with different servers. And they have a list of ones that are recommended.
So what do you do as somebody who probably runs several NTP servers?
I don't run any NTP servers. I rely on other people for time. I don't have a good source of time, so I don't. Basically, I don't have enough machines in one place where it makes sense to get the time once for the internet and then distribute it myself. if you have hundreds of machines, it does make sense to have a time server on your network instead of having all of those connect to the internet all the time.
Yeah, that makes sense.
So a little bit more about the implications of this.
Yeah.
Especially with virtual currencies like Bitcoin, an inaccurate clock could cause Bitcoin client software to reject what is actually a legitimate transaction. So you can cause them to reject stuff that's supposed to be good or a bunch of other interesting things like that. And then it describes how much error you'd have to induce in people's clocks to take advantage of different things. For example, with TLS certificates, you probably have to change their clock by months or years, in that you can either make a certificate that is invalid by changing the clock to be before the certificate was issued or after it expires, or if there's an expired certificate, maybe even from many years ago before the algorithms were as strong, you could offline crack that, right? Like we know that 512-bit RSA isn't that strong anymore. Well, if you go back and get a copy of the 512-bit RSA certificate for Microsoft.com from the 90s or something, and brute force it, then you could skew someone's clock to make them accept that certificate, right, as being valid. And then you would be able to do a man-in-the-middle attack. And so it's very important that the clocks actually be accurate. It was interesting when I taught the Unix security class and we were dealing with SSL certificates. It was actually a problem that the machines in the lab often had incorrect clocks, and when you ran a VM on them, the clock in the VM would inherit the clock time from the host machine, which was wrong, often by more than a year. And all of a sudden they were like, well, I can't get it to accept the certificate from, some legitimate website. It's like, well, you see the error message says that this certificate's not valid yet? It's because your computer thinks it's a year ago. And so if you fix your clock, all of a sudden their certificate will work. I think this is actually for PGP encryption. When we were doing that as part of the class, it would end up being like, sorry, I can't encrypt that key because it's not valid until 2 months from now. I'm like, oh, if I fix my clock, all of a sudden it works fine. So an interesting attack here is HSTS. You remember that's the HTTP secure transport thing? So basically it's a header a website sends you saying, I will always have an encrypted connection to you, right? But for the sake of sanity, that includes an expiration date so that someday we might decide that we're switching to HTTP 2 or something, and that's not necessarily going to be the same. Or maybe we decide that SSL isn't worth it for something. Who knows? But there is an expiration for that. If I can screw with your clock enough, I could set time forward far enough that the HSTS header for Google.com is expired.
Yeah.
And then when I do SSL stripping and convince you to connect to Google without HTTPS, your browser won't freak out like it would now. Or for DNSSEC, if you skew it by just a couple of months, then you can make DNS validation fail, right? Because they won't have issued a key for that future time yet. And so your client will reject their packets or accept invalid ones. DNS caches. If you just go forward by a couple of days, then the whole cache goes away.
Expires.
And then it's easier to it'll be easier to spoof things.
Yeah.
Routing. If the routers are actually even using PKI in routing, if you shift the time on the router by a couple of days, then it might accept an invalid update. Or just refuse to route packets because it doesn't have any valid updates or whatever. Like we said, Bitcoin, just by hours, you can make bad things happen.
Yeah.
For API authentication and Kerberos and things like that, just a couple of minutes will make a difference. There's a reason why, when you join an Active Directory domain, your time gets synced to the Active Directory server, because if you're off by more than a couple of minutes, Kerberos will fail because the ticket you get's only good for so long, and it's been more than that long. So then, because there have been a number of issues with NTPD, I have a list here of alternatives to NTPD. The first is NTimD. So the Linux Foundation was like, NTPD has grown a lot, and it basically has a lot of the same problems that OpenSSL has, in that people were paid to add features to it, but nobody was really maintaining it. So they asked TimeNut or well-known time nut, Paul Hennekamp, a FreeBSD developer, to write, basically to fix NTP. And he looked at it and was like, it's going to be easier to start from scratch.
Right.
So sponsored by the Linux Foundation, he's writing a new NTP client from scratch. And it's there on GitHub if you want to play with it.
Okay.
OpenBSD has their own called OpenNTPD. It, again, doesn't have, it's near the number of features of NTP, but it's designed to do what you need, which is keep the time on your laptop correct. It has a very interesting feature. It can validate the sanity of the information it gets from a time server by HTTPS.
Oh.
So what it does is make a request to some websites you indicate, like, say, google.com, over HTTPS, right? And then in the response, there's a date field. Now, that's because of latency and caching and other things, you can't trust that that time is exact, right? So you don't want to set your time based on that. But basically, so it gets the time from the time server, and it gets the time from Google or whatever websites you decide you trust from the date header, and then it compares them. If the time it got from the time server is more than so many seconds or minutes or days out of whack, it will just not trust that time server anymore. So basically a way to do a sanity check, saying, this is what time the time server told me it was. The time server is telling me it's 3 years from now. Google says it's not 3 years from now. I think that time server is lying to me.
Yeah, nice.
I'm going to ask a different time server now.
That's very nice.
So that's a very interesting way, very simple but interesting way to kind of gate some of the things that the time server could try to do to you.
Yeah, just a little sanity.
Yeah. Then there's TLS date, which does it over HTTPS, so you can verify the identity of the remote side and so on. And then there's NTP sec, which is a fork of the NTP client that's having a security improved. So this is a separate project, very much in the same vein as NTIMD, but not sponsored by the Linux Foundation.
How mature are all these? Are these usable mature?
I don't know about NTP sec.
Okay.
They were specifically referenced in the notes from the paper about helping solve the bugs. So I don't know if it's finished yet.
Okay.
Last I read, they hadn't published any code at ntpsec.org yet. NTIMD, I think the client is mostly working, but it's not had its first public release yet. So yeah, your only choice are probably OpenNTPD and TLS date. But I'm not making a recommendation. I just use NTP still. So in particular, make sure you upgrade the version of NTP you have to 4.2.8p4, and then that fixes the first two security vulnerabilities.
Yeah, that's the key.
And then, Ars Technica has a long write-up on this as well with more detail and more explanation.
Very nice. That does look quite good. Okay, Alan. Wow, that's a heck of a lot of stuff. NTP is changing guards, as you could say, I guess. It's changing of the guards for NTP.
Well, right now, the original NTP is still the canonical one. We'll have to see what happens as NTIMD and NTPsec actually get finished. But I think it's important that we actually have more than one option for these things, right?
Yeah, no kidding.
So, even like to the point where if you're deploying infrastructure, you would install NTIMD on half and NTPsec on the other half, so that if there's a problem with one, it doesn't take out all of your machines.
True. Very good point. Very good point. All right, speaking of your machines, let me tell you about iX Systems. ixsystems.com/TechSNAP. That's the landing page to go to check out more about iX Systems and support this here podcast. ixsystems.com/TechSNAP. Now, there is so many good things to tell you about iX, but I can tell you from my personal experience, what really stands out from iX is I know that the system I get is going to be reliable, and the software that I run on that is going to work great. And the reason for that is A, the people that have built the system have already heard of the software. That's a huge accomplishment, just a huge, huge accomplishment right there. It's two, the people that have built the software often are the people behind that software, the people that know about that software, the people that are creating that software, and they're not going to point fingers at another vendor when there's an issue. And then last but not least, one of the things I love about iX Systems is they're in it for the long term. And this is a big deal for me because if I'm going to bet my reputation in a company on a hardware vendor, if I'm going to say I think we should switch to iX Systems, I have a lot of comfort in knowing they've been around since before the first .com big bubble went pop. They've been in this for a while, and they figured out how to build a sustainable business. And in that process, not only did they build out an incredible bench of developers, support personnel, sales staff, they've also created incredible relationships with the industry, the hardware providers that give them the things directly. So, for example, Allan, I believe they had a get-together at a hard drive manufacturer. Like, was it who was it? Western Digital? Who was the company that hosted one of their get-togethers not too long ago?
When we had Meet BSD, the conference sponsored by IX, we did it at Western Digital, yes.
Yeah, it was Western Digital.
2 years before that, it was at Yahoo.
Now, here's why I bring this up. There's something really special that happens when you work really closely with the people that make like the good hardware that you want to use. When you bring in the people that develop the software that runs on that hardware, and you have a sales staff and engineering staff that actually really know how to implement this stuff. Something really nice happens when you interact with them as somebody who's trying to just get a project done, because you're coming at them usually from the perspective of, I need to get XYZ built, I need to accomplish XYZ project. When you're coming at them from that perspective, they have an incredible bench that they can go to help you get everything you need to get just the right system built. And the nice thing about that is it's sort of your on-demand expertise. So there's always somebody that knows a little bit more than you do, and there's a good chance they work at IX Systems. And you might be an expert in all the other areas, but they can fill in the gaps where you don't have it. And if nothing else, you know that if they're backing up what you're saying, you can rely on it. So that's also kind of nice. I want you to check out ixsystems.com/TechSNAP. They have storage servers. They have great systems you can use for anything from the small business, like we have here, a FreeNAS Mini, all the way up to the high-end stuff, and like the stuff that Allan runs. It's way fancier than the stuff I have here at Jupiter Broadcasting. And Allan's got a whole set of rigs, and I can tell you, he would know if there was if any shenanigans. I mean, really, Allan, Scale Engine essentially runs on IX, and that's a huge statement right there.
Yeah, and they were also a sponsor of the OpenZFS Dev Summit I just got back from. But I think the biggest one was actually just a quote I saw on Twitter the other day. Someone who had just bought some hardware from IX and like, I've heard Allan describe the IX experience so many times, and I was still even better than I expected.
That's awesome.
And I think that's the thing. It's like, as much as we sit here and rave about it, just try it, and you'll be like, oh,
that was before,
I understand now.
I got my FreeNAS Mini before they were a sponsor, and that was also my experience.
Yep.
I was like, oh, wow, that was actually even better than I expected. ixsystems.com/TechSNAP. Go check them out. And a big thank you to IX Systems for sponsoring the TechSNAP program. And thanks to you guys for visiting our sponsor. Okay, Allan, so I feel like we started a process a couple of weeks ago where we mentioned things about Flash, and we even mentioned a few things about Java. Last week we had a story about Flash, and this week we've got a story about that story, correct?
Kind of, yeah. So basically last week we were like, oh, turns out there's this Flash 0 day, but it's only being used against the government. It's okay. But Adobe has finally released the fix for that. So all users of Flash should upgrade to 19.0.0.226 so that you will be safe from that vulnerability. And I'm sure that next week we'll have a story about how somebody's reverse engineered the fix, and now the 0 day is, or well, not a 0 day anymore. The vulnerability will be added to all the regular exploit kits, and everybody who doesn't upgrade to Flash 19.0.0.226 will be in danger.
In other words, the dinner bell is ringing.
Yes. So hurry up and upgrade, and then you'll be safe. But I also included links to Krebs has an article on how to set up click-to-play mode so that Flash won't run automatically for the things where you maybe want Flash, like, say, the live stream of TechSNAP. You can click to start it, but Flash ads won't auto-start, and more importantly, hidden iframes with embedded Flash that maybe has an exploit will just never do anything on your computer. So, you know, if
it's a pretty easy
like
fix.
me, you still need Flash, you should set up this click-to-play mode.
It's a pretty easy fix.
Yep.
Yeah.
And then Oracle has released their quarterly patch update for Java. You know, they basically hold all the updates and do them a couple times a year. Well, they say quarterly, but sometimes it's more. Hard to say. Anyway, it addresses at least 25 different security vulnerabilities.
Hey-o.
And according to Google, all but one of those are remotely exploitable without authentication.
Oh, nice. Nice.
So, like, all but one of these is the worst possible kind there is.
Right.
Instead of being like, you know, oh, don't worry, all but one of these are just minor. It's like, no, all but one of these are the worst possible thing.
Thank you, Oracle. Thank you, Oracle.
Yeah.
Update 65 for Java 8.
Yes. Make sure you're running Java 8 Update 65. And again, consider click-to-play mode for Java as well. Mm-hmm. Or even, you know, I actually do need Java for one or two things. So Krebs says, alternatively, consider a dual browser approach. So having Java off in your default browser, but on in a secondary browser that you only use for those special things that need Java. And he points out that Java version 8 includes an option to let users disable Java content in browsers entirely from the Java control panel. So by going to the Java entry in your Windows control panel, you will be able to just say, hey, don't ever bother with running it in the browser. That way you don't, especially if you have multiple browsers, you don't have to go to each browser and make sure the settings are always correct. You can just say, hey, Java, never run in a browser. And that's mostly what I do because one of my 2 uses for Java, I can get rid of it by using a desktop Java app instead of a browser-based Java app.
Yeah.
And on top of the desktop one actually being better, it solves the obvious problem of
right.
How do you...
you know what, I've kind of... so I've done this for Flash. I only use Flash in Chrome. I have Google Chrome installed for Flash stuff that I need to use, and then outside of that, I don't have it for any of my other browsers on my system. They don't have access to it. I don't bother installing the plugin.
Yep.
I could do the same thing for Java, I suppose.
Yep.
All right, sir. Good. Very nice. Very nice. Nice. Like, sort of a completion there to the story arc. Any other notes on that one?
No, that's all I have for that one.
It's nice to actually see hey, this is happening, but don't worry, it's only affecting the government, to now here is the actual fix. By the way, you could also just click to, and also there's plugins too that'll do this for you. I don't know what the difference is between implementing it. I would assume it's better implemented at the plugin level, but there are dedicated browser plugins that will enable click to Flash or click to Java as well. So you can look into that. All right, Allan, tell you about something else you can look into. That's Ting, my mobile service provider. TechSNAP.ting.com, TechSNAP.ting.com. That's where you go to support the show and get a $25 discount. Ting is mobile that makes sense. No BS. It's just you pay for what you use. It's flat $6 for the line. So, if you want a few lines, like I have 3, $6 for each one. Easy. And then your usage on top of that. They take your minutes, your messages, your megabytes, whatever it adds up to. That's what you pay. They have a savings calculator on their website, so you can go see how much you would actually save. No contract, no early termination fee. I love that. Each phone is unlocked. They have super passionate support, and they have an awesome control panel. But if you're even just a little bit savvy, you can really take advantage of the Ting service. They have 2 CDMA they have 2 networks, a CDMA and a GSM network. So start with that. Think about in your area, what's better? What has better speed? What has better coverage? You can game that a little bit and say, you know what, I'm going to go GSM. Or you know what, I know because I got a lot of trees and hills, I'm going to go CDMA. What I also love about Ting is you can just swap that SIM card. So you can get the GSM SIM card, you can get the CDMA SIM card, and you go with like a Nexus device. Not only are you getting a Google device with the Google updates, but it will go CDMA or GSM. I've done that with my Nexus 5, and it's really nice. And the really cool thing about Ting is they have incredible dashboard. Very good. Better than all of the other cellular providers out there. I can tell you that based on my testing firsthand. They have a very good dashboard, and I've never really needed to call customer service for anything. I have, mostly just to see if I can do it. But you can use, really, because I talk about it all the time, so I'm like, I should probably call in. But really, their dashboard, you can transfer devices, move from GSM to CDMA, monitor usage, set alerts, turn stuff off, turn a device off completely, which is really nice for the hotspots. You go get a Ting hotspot, and it's just $6 a month, and then your usage, and then when you're not using it, turn it off. Why not? I love that. And by the way, because I use Wi-Fi for a ton of stuff, like everything, all my things, all the things, even for calling, Wi-Fi up in this business, my Ting bill for 3 lines is like $40 this month. It's nothing. TechSNAP.ting.com. Go there, try it out. No contract, no early termination fee, and you support this show. And look at this. The Ansatel One Touch Fling. No, not that kind of fling. The cell phone kind of fling. $38. $38. No contract. No early termination fee. You pay for what you use. Now, what's great about that, later on you want to go to something fancier, no bigs. You just go get that device, put it on your Ting account, and then it's the same price. It's the same monthly price. And I also think, maybe if you want something that is an actually, decent Android device, something that's going to actually get updates and be secure, check out the Moto G. They got all of them, but they got the 3rd generation up on Ting, $180, no contract, unlocked, you own it. TechSNAP.ting.com. You get an actually well-built Android device that's getting updates for $180, no contract. TechSNAP.ting.com. They got data devices. They got all the phones. So they got all of them. They got the new Nexuses. They got the iPhones. All those things. You can go get them. TechSNAP.ting.com. Go try them out. Call them at 1-855-TING-FTW if you got any questions. And also play around with their dashboard. And then I'll just point out too that you can just straight up buy a SIM card for $9 for their GSM or CDMA networks. If you have a device or a phone that's sitting around that takes a GSM SIM, you can pop that sucker in there, or a CDMA SIM, pop that sucker in there and give it life. And then you just pay for it when you use it. I've seen people use this for their security systems, for backup phones, for a car phone, for an accident, for a kid's phone, all kinds of things. TechSNAP.ting.com. And a big thank you to Ting for sponsoring the TechSNAP program. Oh, I like that. I had a little. I could get that. Yeah, there we go. All right, Allan. So I don't know how the hell you did it since you were traveling yesterday, but somehow you actually released another episode of BSD Now.
Yep.
It must be with help of that Rikai guy. I bet he had a head in it. Might have had a hand. So tracing the source, episode 112 of BSD Now. What's this about? Do you remember? Has it been too long?
This is our interview with Adam Leventhal, who is the guy that wrote the RAID Z2 or RAID Z3 implementation for ZFS.
Oh, cool.
And also was one of the key people on dtrace and a bunch of other interesting things. So it was a really good interview that I know a lot of people that were at the ZFS hackathon were interested in seeing.
Very nice, Allan. Very, very nice. Well, I will be...
And unlike some of the other ones while I've been away, that is an entire full episode, not just an interview.
Okay. Very cool. And you can find it at jupiterbroadcasting.com, episode 112. I'm going to give a plug since we are pre-recording next week for TechSNAP. Well, I'm traveling. I'll be traveling to Colorado to visit System 76. And two things I want to make you kind of aware of. Number one is if we have a meetup, if we decide to have a meetup, we're still kind of figuring all that out, meetup.com/Jupiter Broadcasting. If you're in the Colorado area, I think System 76 is in Denver. I probably should have looked that up.
Yep.
I should probably have looked that up. But you can find out. And if you're interested, meetup.com/Jupiter Broadcasting, you let us know just by signing up and saying something over there in the forum. And also, while I'm traveling, you'll be able to find a new Rover log at jupiterbroadcasting.com/Rover. And there has been a few updated recently as well. So those are always sort of the traveling Rover log as we go. So you can catch more episodes. And if you haven't watched it before, there's about 14 of them. And they're all pretty short. I don't think any of them are much longer than 10, 11 minutes at most. Most of them are around 7 minutes. jupiterbroadcasting.com/Rover. Okay, Allan, with the news all done, that means it's time for the TechSNAP feedback. Thanks for sending your emails to techsnap@jupiterbroadcasting.com or pop in that contact link at the top of the Jupiter Broadcasting website or starting a thread in our subreddit at techsnap.reddit.com. Ryan sends in our first email this week. He says, "Hey guys, almost weekly you answer questions about bandwidth issues, and I was hoping that you could inform your audience about the correlation between TCP and distance. In particular, you had a viewer ask about bandwidth issues with their DO droplet while doing a speed test. Even though their droplet is connected to the internet with a gigabit link, using TCP will limit their actual bandwidth of a single TCP transfer by the time it takes for the packet to reach the destination and return packet acknowledging its recipient or receipt. Since packets can't move any faster than the speed of light, this becomes a bottleneck. UDP won't have this issue if your application can support multiple simultaneous TCP sessions, and you can overcome this. You guys do an excellent job of explaining these things, and I was hoping you could share this with the TechSNAP viewers. In my last job, we tried to explain it to one of our senior network engineers that the max bandwidth between two of our sites on either side of the U.S. over dedicated fiber was limited by the speed of light. He wasted thousands of link tests because he thought we could get a full 1 gigabit transfer over the line with a single TCP session. Also, do you recommend any open source WAN acceleration software? Is there anything special Allan uses to overcome this with servers deployed all over the world? If you could explain what Riverbed, Bluecoat, and Citrix do to warrant spending thousands on their hardware, that might help your viewers understand these appliances if they ever encounter them in the workplace.
So, hate to say this, but you're wrong. That's not how TCP works. First of all, if TCP waited to send the second packet until it got the ACK for the first packet, we would still be waiting for stuff to happen. So, first of all, TCP has a concept of a window. So it will send multiple packets. And then eventually, once it's sent too many, it'll wait till it's got an ACK for the first couple and then send some more. So basically, the windows defines the amount of data that's allowed to be in flight at once. So back in the day, possibly when you learned this stuff, we had the concept of what's called the bandwidth delay product, which basically said if you have a link that's this wide and it takes X milliseconds to get to the other end, then you have a bandwidth delay product of X. And this is basically the most amount of data that can be traveling across the network at once, based on you're sending at this speed and it takes this long to get to the other end. And if that bandwidth delay product was higher than 64 kilobytes, which was the default maximum size of the window in TCP, then yes, you would be limited. That would limit your speed. And so no matter how fast your connection was, if the other place was too many milliseconds away, you would be slowed down. But then we introduced what's called TCP window scaling, which came out as part of RFC 1323 in, I don't see a date on it right off the top of my head, but a long time ago.
A long time
1992.
ago. Okay.
So basically, because the field that we store how big the window is in TCP is 8 bytes. Anyway, the biggest number it can represent is 64,000, or 64K, which is 65,532 or whatever. That limited how big the window could be. And back then that was a lot. Now 64 kilobytes is not a lot. So they used one of the extra bits in the option field to express a left shift. Actually, I think it's 2 bytes. Yeah. So now the maximum allowed size of the window that you can set for the amount of data that can be in flight over the connection, instead of being limited to 64K, which would limit the speed that you could send to a link that's far away.
Yeah.
The limit is now 1 gigabyte, or 1 gigabyte minus 1 byte.
Right. Okay.
But basically, a billion bytes. Now, most people don't set theirs that high because that would mean you would need a gig of RAM for every connection just waiting to receive bytes. But by adjusting, and then we have window scaling that's automatic. So based on how things are, based on how the connection is going, you might up this higher and higher each time. But basically, with TCP window scaling, you can change the amount of data that's allowed to be in flight. And as long as you set that bigger than the bandwidth delay product, then that means you can actually saturate the connection.
Okay.
And that's how I can saturate a connection from Portland to Toronto, which is basically the same distance as, the average of across the US somewhere.
Yeah.
And I can do a full gigabit across that without having to pay for any WAN accelerators or anything silly like that. It's just a matter of tuning. And mostly, it's not something you have to do anymore. Your operating system just does it. So in the case of this guy's DO droplet, it was the fact that the link was just saturated somewhere and that amount of bandwidth wasn't available. But it's not limited by the speed of light. Basically, that was a limitation at one point, although it didn't quite work the way he described it in here of, TCP has to wait for the ACK before it can send the second packet. It's more that, TCP will send up to, there's 2 limits. There's one on the sending side, and then there's one on the receiving side. And the reason for that is so that if the receiving side is like a really slow device, it can say, don't talk so fast so I can actually hear you. Right? If it can only copy so many bytes at a time, then it'll rate limit the connection. Basically, both sides cooperate on rate limiting the connection. And you can basically, we've lifted the limit of 64K so that we could deal with the fact that, I have a gigabit in Toronto and a gigabit in Germany, and I want to be able to send really fast.
Right.
Because one of the interesting things is when you were using SSH to do transfers, it had a defined buffer of 64K, and that caused that same bandwidth delay product problem to happen if you were transferring things over SSH, even after we fixed it at the TCP layer. And that's when SSH, somebody wrote, I forget which university, but a university wrote a patch for SSH that enables what's called high performance networking, or HPN, which takes out that bit of code and lets the operating system's TCP stack handle the rate limiting. And that meant that all of a sudden now you can do SSH transfers at 40 megabytes per second from Toronto to Germany without a problem. So maybe that's why you couldn't convince your network engineer about bandwidth delay product. The problem is that doesn't work like that anymore.
Yeah.
It used to. That used to be a thing, but now it's not.
Well, Allan, that was actually pretty fascinating. I'm glad that guy emailed that in. That's a great example of a question where we can get into a really interesting discussion. So thank you, Ryan.
About the devices he mentioned, I've never heard of any of those, probably because I've never needed one, because like I said, I can actually get a gigabit on a single TCP connection from, somewhere like Portland to my house without a problem. Or, oftentimes you can't quite max out the whole gigabit over the Atlantic, but that's because I don't have a dedicated pipe there, right? That's using a shared line, and there's a lot of other stuff going on there. But anyway.
All right, are you ready for Corey's email?
Sure.
All right, so Corey's got a problem that he's been on a quest for, Allan. He says, for many years, I've been searching for a tool or a combination of tools to create an encrypted remote-mounted file system. Now, stick with him before we go too far. A virtual file system such that when I save a file, it will encrypt and save the data on a remote server without keeping a local mirror and without unencrypted data leaving the local machine. That seems simple enough, but my research keeps running into dead ends. I've investigated several combinations involving IncFS, reverse and forward, encryptFS, DMcrypt, SSHFS, but all of those failed for technical or performance reasons. I would like to be able to use Unison to effectively synchronize my local files with encrypted copies on the remote server. The local machine runs Ubuntu. The remote server could be any flavor of Linux or BSD. Keep up the great work. Corey.
Right. So the way he said he didn't want a local mirror might slightly complicate it, but there's a couple of options there. So it sounds like in the end what he wants to do is save files to his computer and then have them replicated remotely to another place, but have the encryption done on his computer so the unencrypted version never leaves his computer.
Right. What? So
something like PEFS, PEFS, we covered that a while ago on BSD Now. This sits on top of a regular file system and does this. So you could do PEFS on top of something like SSHFS, and that would accomplish that. One of the big things to remember is that most of these disk encryption things aren't designed to stand up to the type of attacks you would get on an internet connection. So another option is use something like Geli, which is part of FreeBSD, and that's the disk encryption. But you don't want to just stream Geli over the internet because it's not robust in that manner, right? It's meant for your hard drive, not for. It doesn't stop people from modifying packets in flight and so on.
Right.
So you can do iSCSI over the internet, and then that gives you a block device on your Ubuntu machine, and then you can apply whatever encryption your OS likes, like DMcrypt or Geli or whatever. And then in that case, you basically have a second drive mounted on your local machine that you can Unison to or whatever. And then the data is actually stored on some other machine, encrypted, and you can always mount it there. But he didn't seem to want to have that second drive mounted on his machine, so I don't know what to recommend.
Well, yeah. What about,
So I would say the one that sounds most like what he wants is something like PEFS, which basically sits over top of a regular file system.
Yeah.
So when you create a file, it's stored on the regular file system as a file, although the name is also encrypted, so it just has gibberish for a name, and then inside the content is gibberish. And then when you match it with the keys, it's a layer that sits over top of that, and you see your directories with real file names and the real content.
All right, I'll take it. I was trying to think of a better solution, but honestly, Allan, I can't really come up with one. Maybe people can let us know, techsnap.reddit.com or techsnap@jupiterbroadcasting.com. So Danny writes in...
I just use tarsnap.
There you go. Also a popular one amongst the Linux Action Show crowd, too. So Danny writes in with our obligatory ZFS question. He says, "Hey guys, keep up the great work." He says he really enjoys the show. I'm looking to putting together a ZFS-based NAS for a home use, and I was looking for some guidance on configuring the pools. Initially, I'll have 4 2-terabyte disks in the NAS, and I'll expand as it becomes necessary, and well, funds allow. I've been doing some reading and finding split opinions on whether to use RAID Z2 or mirrored pools. Could you throw in your 2 cents in this discussion? For a home NAS, what would be the benefits or actually the drawbacks of using a mirrored pool versus a RAID Z2? Would you recommend one over the other? Thanks for the help, Danny.
Yep. In general, for that, especially if you have plans for expansion, I would say mirror sets are best for a couple of reasons. If you do all 4 disks as a RAID Z2, then ideally, if you add more disks, you would have to add 4 more at a time. Whereas if you do that as mirrors, right, 2 terabytes and a second 2 terabytes, you can always add 2 more disks. You can upgrade 2 disks at a time instead of 4 disks at a time,
which is much more economical.
Yes, and especially if you just happen to be starting with 6 disks, then 2 at a time instead of 6 at a time is a much. Now, you don't have to add, the same size as your original, but you don't want to mix types. So if you start with RAID Z, all of your groups should be RAID Z. They don't have to be the same size, but they should all be RAID Z. When you only have 4 disks, RAID Z and Mirror both have the same amount of usable space. And so the fact that mirrors are faster it's like, well, why would I do RAID Z2 when it, normally the reason for RAID Z and RAID Z2 is that it's more space for the same money compared to mirrors. But with 4 disks, that's not true. The only advantage to RAID Z2 in the 4 disk case is it means you can lose any 2 drives. Whereas with the mirror sets, you have 2 drives as one mirror and 2 drives as a second mirror. You can lose 2 disks as long as they're not both from the same set, right? So, RAID Z2 might be slightly less likely to lose your data, but as long as you're really only worried about losing 1 drive at a time, then it doesn't actually make a difference there. So mirrors would be better. You'll get more IOPS and performance from mirrors, especially your read speed will be higher. And you'll be able to add 2 drives at a time, which is better.
Yeah.
Also, it means for upgrading, you'll get the benefits sooner. So eventually you're going to run out of slots in your NAS, right? You only have so many SATA ports and only room for so many drives in the chassis. Whether that's, 6 or 8 or 10 or whatever. When you do hit it, your option for upgrading then is to replace all the disks in a group with bigger disks, right? So, when you started, you bought with 4 2 terabyte drives. When you do your next upgrade, that might be 4 terabyte drives. And then when you do your upgrade after that, maybe it's 6 terabyte drives, right? And then you're out of slots. So then you've bought 2 new 8 terabyte drives. So you would just replace one at a time your 2 terabyte drives with these 8 terabyte drives, and you would just get, 6 terabytes more space. Great. If you do RAID Z, then you would have to upgrade the 4 or more, however, are in your group at a time. So if you only bought 2 disks at a time, you'd upgrade 2 of the disks and get no benefit until you upgraded the other 2.
Right, and that's the key thing.
Yeah, and the other thing with the mirrors is means with RAID Z, they all have to be the same size. With mirrors, only the 2 in each pair have to, right? So you can get away with doing, 2 2s, 2 2s, and then 2 3s, and then 2 4s, and 2 5s, or whatever. Whereas with RAID Z, you need 4 drives that are the same size, at least for each group.
That seems pretty, actually, when you break it down like that, that seems pretty obvious.
So, yes. Well, basically, mirrors are always better, but at some point, mirrors cost more money because you only get half the space out of each drive. Whereas with RAID Z, you only lose 1 or 2 or 3 drives out of each set, which could be, 8 or 10 drives or whatever.
All right. Are you ready for the next one?
If it's one other thing for that mirror. Oh, also, if you're really paranoid, you can actually do deeper mirrors. So you can have mirror sets where there are 3 drives in each mirror, which will give you even more read speed, but waste even more hard drives, basically.
Ooh, interesting.
But yes, you can get really high read speeds.
Yeah.
Although your write speed doesn't scale up because you have to write all the data every drive.
Yeah.
But, some data is that important that you want to have 3 copies of every byte.
Well, or, actually when you said, of course, I can't help but make it about me. I was thinking about for editing, the reading for when you're rendering and applying effects, the reading is so critical.
All over, yeah.
Yes, yeah.
Although,
I'm building a future system, Allan. I'm building.
Depending on the size of your setup, you solve that with ZFS with the ARC, so you can keep like 60 gigs of files in RAM.
Yeah.
Nothing's faster than RAM.
Right. Yeah, oh gosh.
Or you have an L2 ARC SSD, right? So even though you have lots of these, you filled the machine with 5 terabyte spinning drives because you need that much space. You have this, 500 gig SSD that keeps the file you're working on all on an SSD.
Right.
So it's really fast.
The quote unquote episode that's being edited.
Yes. Yeah. Or, technically it'd be your working set. But yes, the episode being edited would all reside on that SSD temporarily. And then you would get that performance boost without having to build your entire storage array out of SSDs.
Yeah. All right, so we have the last email is just kind of a fun one. We don't actually have to answer this one. Jason writes in, he says, I don't know which show I should send this to, but I was looking at Imager and I came across a Chinese woman who made these cool platform shoes, which she put a penetration testing tools in it. She says she packed a Wi-Fi router in there, a 3D printed shoe from it.
Yeah,
the router
so she
has
basically made a 3D printed shoe, and inside the heel of the shoe, there's a Wi-Fi router that runs its OpenWRT and can record Wi-Fi traffic. It's got like a set of lock picks. It's got an Ethernet cable to jack into things. It's got.
It's essentially like a whole kit in one. She says she was inspired by the Mr. Robot TV show. Have you seen that?
No, I haven't.
It's the one nice thing about it is they actually consult with actual computer people, so the commands they're using on screen are kind of legit. It's kind of nice to actually see legit stuff going on. But you can see here, Allan, she slides the top of the heel off of the shoe, and it reveals the machine underneath. How cool is that? That is really neat.
There's a Wi-Fi router, an Ethernet cable, a lock pick set, a USB keystroke recorder. So you just plug this into unplug the keyboard, plug it in through this device, and it logs the keystrokes. And basically everything you need to compromise a business.
She says here, for the purposes of the test version, my right shoe contains the pen testing Dropbox. This is a wireless router running OpenWRT with a built-in rechargeable battery that could be left running inside the shoe for what she calls war walking, Wi-Fi sniffing, logging, etc., or could be removed and plugged into a convenient open network jack as soon as I was in and had direct access to the LAN. Once this is done, you can gain remote access anytime you want via an SSH tunnel.
Yep.
Look at the TP-Link router that she puts in there. A TP-Link router in her shoes.
Yes, the best part is those TP-Link routers run the Atheros chip that can run FreeBSD as well.
Yeah. This is great. Wow.
Yep.
You know, when I worked for a bank, we talked about the Nintendo GameCube that somebody had pulled out all of the guts in and built a little computer in there with an Ethernet jack and was going into banks and plugging in and stealing information from banks. And so we had to issue an advisory to all of our branches to watch out for Nintendo GameCubes. And now you've got shoes. Now you've got shoes, Allan. All right, go to jupiterbroadcasting.com/contact to send your email into the show. And with the emails all done, that means it's time for the TechSNAP Roundup. Welcome to the TechSNAP Roundup. Yeah, that's what that crazy music means. Now, the Roundup are stories that just didn't fit at the top of the show. We still want to give you some links to follow up on your own and read even more after the show. And some of these links came from our incredibly powerful and intelligent subreddit, techsnap.reddit.com. Our first story, I am very happy to say, after being a little disappointed with Lollipop, Android 6.0 is re-implementing mandatory storage encryption for new devices, as long as you meet the minimum speed requirements. And I think this is actually a brilliant way to do it. See, with 5.0, when Android Lollipop shipped, it was at the same time that iOS 8 shipped. And Apple made a big stink that encryption would be enabled by default. In fact, we're going to get to that more in the roundup here in just a moment. But Apple made a big stink in iOS 8 that, encryption's enabled by default. And then Google said, we're going to totes do that too. Yeah, us too. And then they actually never got it implemented because the file speed, the accessing of the files was so bad that the OEMs pushed back. And so they kind of said, all right, we're not going to push it forward. And so now what they've done is they've said, well, we're going to go for encryption as long as you meet the minimum speed requirements. And so here's what they say. Now, what do you think? 50 megabits a second. If you can do
megabits or megabytes?
Well, it's a lowercase I, so I think it's
that's
megabytes.
That's megabytes.
Okay, yeah, 50 megabytes. And I think that's pretty good for a phone. I mean, that's pretty good.
Yeah. So I'm guessing this is basically going to require something like AES-NI offload.
Yes. It is advanced. Yeah, it is AES exactly. It's say you need.
Well, it'd be AES, but basically starting with the ICE core series in Intel, they included this new instruction called AES-NI, meaning new instruction.
And starting in ARM version 8 CPUs, there is also built-in support for that.
Because with that on FreeBSD, our AES-NI implementation can get you to like a couple of gigabytes per second per core. And so on a slower phone type processor where you're worried about battery, this is going to cost a little bit more battery, but offloading it to the CPU means you're spending a lot less work on it, and hopefully will make the battery life not suffer from it.
So I think it's a good step in the right direction, at least. You have that. All right, Allan, next story in the roundup is one of the famous mailing list posts.
Mm-hmm.
What do we have?
So this one is just a note about software maintenance, in particular about OpenSSL.
Okay.
So this is from a OpenBSD developer who's working on the LibreSSL stuff. And so in case you need another OpenSSL anecdote to scare your coworkers with, many of you may remember from your crypto classes in college that DES, or the Data Encryption Standard, which is what we used before AES, which is the Advanced Encryption Standard, basically had 16 different weak keys that have group-like properties. And if you want to know more about how DES works, you can go look it up on Wikipedia. But these are not generally considered a problem. And in any sane situation, keys for DES are generated with a cryptographically secure random number generator. Mm-hmm. Since there are 2 to the power of 56 possible keys, the odds of hitting one of the weak ones is 1 in 2 to the power of 52. That's both you and your computer were independently struck by lightning this year territory as far as what the odds are. So the serious recommendation by the cryptographic community is to ignore the possibility of getting a weak key. Don't check for them and just hope you don't get it. Your random number generator is bad, like the Debian bad, and you're totally screwed already, so it doesn't matter if you got a weak one. Checking for weak DES keys is putting your like putting new vinyl on a Titanic's deck chairs.
Wow.
So yes, if you have a weak random number generator, then your keys are going to be weak. So the other one is, wow, you're unlucky. Sorry about the lightning. You should buy a lottery ticket. Don't worry, the attackers are just going to brute force your DES keys anyway, so it doesn't matter. So anyway, you're more likely to get the check wrong than to ever actually get a weak key. That's a funny way to phrase it. So OpenSSL has optional code that rejects attempts to use weak DES keys. It sanely is not enabled by default. If you want it, then you just compile in the extra option EVP check DES key. So on last Thursday, it was reported to the OpenSSL dev mailing list by Ben Kudek that there was a defect in the original optional code. It had a syntax error, which didn't compile. In particular, it had 2 exclamation marks instead of 2 pipe characters, which were meant to be an or in the statement. Which is interesting because a single one of the exclamation marks could have changed the meaning of the statement, but 2 just caused a compile error. So it turns out that this code has been there since 2004, and it has never, ever, ever worked. It has always caused an error. You couldn't even build a binary.
You're kidding me.
Yeah. The syntax error was present in the original commit,
Love
and
it.
It's been if-deffed out and obviously never compiled once ever.
It's classic. That is kind of a classic, actually, isn't it?
Yes, and it's just like LibreSSL's response, the if-def and the code of them have been deleted. And so it just isn't there anymore. OpenSSL's response, the code that for 11 years was never used and only applies to DES, which nobody should ever be using anymore, was fixed on Saturday.
Nice.
And it retains the if-def, so it's all still off by default.
All right, Allan, are you ready for the next?
You would have just got rid of it.
Are you ready for the next story in the roundup,
Yep.
sir? All right, so this one I've been following with some personal interest. How secure is Apple's iMessage program? Apple claims it's pretty much unbreakable. However, a group of researchers claim that's a bunch of crap. A close look at Apple's iMessage system shows the company could easily intercept communications on the service despite its assurances to the contrary. Researchers claimed Thursday at a security conference. Now, this InfoWorld article manages to go on for what appears to be 3 or 4 pages worth of absolute bogus crap. But here's what you need to know. The company's claim that iMessage is protected by unbreakable encryption is just basically lies. This is according to Cyril Katalix, who has developed an iOS jailbreak software and works for QuarksLab, a penetration testing and reverse engineering company in Paris. Here's the crux of the issue. Apple uses a public key cryptography to intercept and encrypt iMessages between senders and recipients. So, Apple controls the key server. So as an iPhone user, when you send an iMessage, it encrypts that. And let's say Allan was an iPhone user, and I was going to send an iMessage to Allan. When I send that message, It queries Apple's public key server. And Apple's public key server confirms if Allan is legitimate and whatnot, and then issues the key to me. And then I complete the encryption and I send it to Allan. And what the researchers are claiming here is essentially, if Apple was motivated, they could claim anybody was legitimate, including their own key, the NSA's key, somebody else.
Or, in particular, if the police were investigating me, they could have Apple's server tell you, no, the FBI's key is Allan's key, and you will encrypt the message to the FBI, and they'll read it, and then maybe decide to relay it to me anyway.
Yeah.
And because, the problem with using public key cryptography is like when you don't control the keys and you don't get to verify them, then
Apple controls the key server, and so the issue is what happens to the key server. Now, Apple claims
that they're not going to do anything malicious, but it's not architected in a way that they can't, and so you shouldn't use it.
Right. Speaking of iOS 9, the next roundup story.
Yes. So if you remember last week, we talked about Zerodium, which is owned by VuPen, and we don't like them, was offering to pay between $1 and $3 million for an iOS jailbreak if you would sell it to them. Well, it turns out the Pengu guys have released their jailbreak for iOS 9.0 up to 9.0.2 to the public for free because they would rather give it away than let Zerodium have it for whatever their evil purposes.
And it works on the the latest iPhones too.
Yes, which we were, the reason that the reward was up to like $3 million was because it was supposed to be impossible.
Could never be accomplished.
Yeah. So if you look through the list there, it lists 12 steps. Some of them are like turn on the phone.
Yeah.
But basically, it looks like it uses airplane mode to keep it from talking to Apple, and uses what looks like a flaw in the Photos app in order to get access.
Honestly, if anybody in the audience has a current version iPhone, like a 6 or 6S, and is jailbreaking it, and they're running iOS 9 or iOS 8, I would love to know what is in it that makes it worth doing that, because we have covered so many stories where it appears to really be like if you jailbreak it, then you are opening yourself up to a lot of avenues of attack. So there must be something in it, and I'm trying to figure out what is it. Why are you jailbreaking in 2015, almost 2016, techsnap.reddit.com? I'm kind of curious.
Yeah, I can see a couple things where you might want to do or put on your own apps or use pirated apps and stuff.
Yeah, that could be the one. That could be the one thing. But like, what app? Like, what app is not available in the App Store that is only available in the Cydia, whatever App Store? I don't know. But I'd be curious to know. Right. Maybe there's something awesome in there. And then one last story to kind of wrap this all up. Apple tells a U.S. judge it's impossible to unlock the new iPhones. Now, anything with iOS 8 or actually anything before iOS 8, Apple quote unquote has the technological capability to break that encryption or whatever it is, but anything after iOS 8, they say that they don't have the capabilities. Now, what I also thought was interesting in their filing to the court...
They don't say 100% there. They say it's like 80 or 90% of people on iOS 8. Basically, I think if you upgraded from an older iOS to the new one, the data that was brought forward would still be possibly crackable or whatever.
Apple told a U.S. judge that it could access 10% of its devices that continue to use older systems, including the ones that were in a case that it's currently in the court for. But... it says, and it urges the court not to make it decrypt them because forcing, and this is a quote from Apple, forcing Apple to extract data in this case, absent of clear legal authority to do so, could threaten the trust between Apple and its customers and substantially tarnish the Apple brand, according to an Apple lawyer.
Yeah. All right, so in this particular case, the phone that the, I think it's the Department of Justice or something, is asking Apple to crack is actually one that they could crack. They're like, we can't crack any of the newer phones, but that particular one we can.
We could do this one, but we don't want to.
We don't want to, and so apparently there is actually like a search warrant in this case, but yeah.
I like though that they say it's still not a clear legal authority. I kind of like that they're just putting that out there. And the other thing is, I genuinely like this because it's not as part of a PR blitz. It's not part of a keynote. It is just what they're doing as part of a legal process when they're trying to get access to somebody's iPhone, and Apple's trying to set the boundaries. And the thing that I like about that is we get to kind of see does the rhetoric match the actual actions? And here they are in a court case pushing for the actual actions that do seem to match the rhetoric, which is encouraging. Now, something we have talked about that is extremely discouraging, passwords. And that's why Yahoo has a solution to solve it all. Well, at least if you're using the new Yahoo Mail. Have you seen this, Allan?
Yes, this is the Yahoo Mail app.
Yeah.
So I think it only works on mobile devices.
Yeah.
But instead of having to log in with the username and password, when you attempt to log in, they just use a push notification to allow you to authorize yourself to log in.
It's like their own two-factor then?
Well, it's not two-factor because you don't still have a username and password. It's just replacing a password with, do you control this device?
It's like identifying you with the push notification.
Yeah.
Essentially. Okay. All right. Interesting. Yahoo Mail, and they've got a lot of other new features. Hawaii, we like to talk about them from time to time because I've been following them for a while. Now, I don't know what to make of this one. This comes from the Register remote code execution hack hole found in Hawaii 4G USB modems. That's according
could
to
allow the attacker to hijack the connected computer.
Yeah, that's according to Positive Technology researchers. They say it's been now since patched, but they say that the Hawaii 4G USB modems could allow attackers to hijack connected computers. It's the E32727 or what is it? Hold on, let me get closer.
E3272.
Thank you, sir. I think my vision is getting not so good. USB modem sells for about $120 on Amazon, so it's probably pretty popular if it's going for $120 on Amazon. But they say the vulnerabilities are exploitable through malicious packets sent to the device's gateway, thanks to cross-site scripting vulnerability and Stack Overflow holes. Now, I don't know.
Attacks on SIM cards via binary SMS messages.
Yeah.
Interesting.
Yeah, they say in November it revealed massive holes allowing hackers to send SMSs to the 4G modems and gain backhead. They say beachhead on the connected machines. We're going to start calling it beachhead access now? Is that a thing?
Well, it just means...
I know what it means.
You've landed there. You haven't done anything yet, but it's a way to
It just
get
sounds
to the device
semi-debaggery, that's all.
A little bit.
Yeah. All right, next story in the roundup comes from Krebs on Security. Don't be fooled by fake online reviews, part 2.
So if you remember the story we told from Krebs' blog before about the guy who was moving and the moving company packed all his stuff up in a truck and then never delivered it. Well, they have more news on that story. It turns out the U.S. Department of Transportation has closed down the company for safety violations not having to do with the guy's stuff.
So don't believe online reviews because they could be completely crap and lead all your stuff to get completely misplaced. So
the interesting one here was that, it's up to the FTC to actually stop this SEO sandbagging stuff and, the fake reviews and so on. And apparently they'll be holding a public workshop in Washington, D.C. on October 30th to discuss consumer protection issues surrounding lead generation industry and the fake reviews and so on. But I've heard of companies being fined before for fake reviews and things like that. So
yeah, me too.
Yeah. It's too bad that this particular company didn't get gone after for that as well.
Here's a story I've been following with some interest. Apparently, John Brennan, the director of the CIA, had a AOL email account with classified, even so classified like things about torture and things like that in his AOL email account. And it appears much like I can't remember the guy's name. He was a blogger, Allan, and his iCloud account got compromised. Matt.
Matt something.
Yeah. Well, do you remember how essentially they did a series of compromises to get to his iCloud account with Amazon and whatnot? Same thing here. These Verizon and then AOL, and they were able to get to 47 different documents accessed by included 47-page application that Brennan had filled out to obtain his top secret government security clearance. Millions of applications.
So that has lots of information about
him,
the guy in particular,
The hacker, who says he's under 20 years old, told Wired that he wasn't working alone, but that he had 2 other people worked on the breach with him. He says they first did a reverse lookup of Brennan's mobile phone number to discover that he was a Verizon customer, and then one of them posted as a Verizon technician and called the company asking for details about Brennan's account. This is a quote from them. They say, "We told them that we work for Verizon and that we have a customer on scheduled callback. The caller told Verizon that he was unable to access Verizon's customer database on his own because our tools were down," which is probably a pretty common line.
The funny one there is they were perfectly willing to give away this information, but their computer was down.
So after getting that info, we called AOL and said we were locked out of our AOL account. They asked security questions like the last 4 on the bank card that we had gotten from Verizon. So we told them that we told them that, and they reset the password. AOL asked us for the name of the phone number associated with the account, of which the hackers then obtained from Verizon. This is almost exactly what happened to Matt Honan.
Yep.
This is like and only they got the director of the CIA. They got the director of the. We covered more of this.
Why he was storing anything like that in AOL account is a bigger issue.
And Hillary Clinton's going like, no, I didn't have any of that in my inbox. We covered more of this in this week's episode of Unfiltered. All right, Allan, then we have another one from Cisco's Talus Group, right?
Yes. So this is actually a project they're starting. If you remember when we talked about the recent one, there was that hosting company, and they gave Cisco all the details about the bad guys and let them get image copies of the servers and so on. So Talus is extending this program, and it's like, hey, if you are a hosting company and you happen to end up hosting malicious stuff, especially botnet controllers, command and control servers, stuff like that, just call us here and give us the information, and we'll be glad to help you out.
Very nice.
And because basically they want the data on the bad guys, and they'll help you solve the problem and clean up your network and so on in exchange for that data.
All right, so Tim Berners-Lee has been warning about the web possibly getting closed down and appears to be looking at Facebook askance.
Mm-hmm.
What's going on?
Well, in particular, Facebook is talking about this project to provide internet in the in poorer parts of the world. Mm-hmm. But by providing internet, they mean providing access to Facebook. So they would give you an internet connection that could only go to Facebook.
Right. For free. For free. What more do you need? Mm-hmm. Sounds like AOL all over again, doesn't it?
Yep.
All right. And then we have got an update on Boring SSL, right?
Yes. So Boring SSL is Adam Langley and some other people at Google had, originally they called it a fork of OpenSSL, but they described in detail here what they actually did was start an empty repo and then copy and paste parts of OpenSSL and then clean them up. So they, rather than taking the approach that LibreSSL did, which is take a whole copy of OpenSSL and start ripping stuff out, they took an empty repo and started only bringing over the parts of OpenSSL that they needed. Mm-hmm. In particular, they make a point to say they don't recommend that anybody else actually use Boring SSL. It's specifically designed for Google products, and most other applications won't work because they've taken out so much stuff. Whereas LibreSSL, they try to leave the stuff that people use in, right? And just take out the junk. But in Boring SSL, they've ripped out a lot of stuff, and then they've changed some of the APIs and so on. And in particular, they say, you don't want to just grab Boring SSL and start using it because we're going to keep changing it radically. And, the fact that it's only used in Google products means that, if we make a change to the API, we just update the applications and it works fine. But you probably don't want to have to rewrite the API in every one of your applications every time we do a new release because we're not going to provide a stable API. If you're looking for a stable API, something like Amazon's S2N or the libTLS from LibreSSL are probably better.
All right, sir. Now, I wanted to follow up on this. Boy, this has been a mobile-heavy one. Battery tests now going on from Consumer Reports show that depending on which iPhone you got versus the TSMC chip or the Samsung chip, there doesn't appear to be any appreciable difference in the actual performance or battery. They called it their chipgate test, and they went through and tell you how to identify the chip. They did that, and then they did some real-world tests, and their bottom line is that they found no appreciable differences in battery life or temperature between the iPhone 6S models with varying chips. Just kind of wrap up from our previous one. So there you go. It appears in real-world usage there's not a huge difference, but you can read more.
But they did find a temperature and battery difference. It just didn't seem to be as big as we had heard about.
Yep. Which I bet, but still makes me wonder, if maybe does that mean in gaming, maybe one chip is better? If you're really pushing one thing over the other,
possibly
there could be more testing to be done. Okay, Allan. Last but not least in the roundup, we got a GitHub link. What is it?
This one is the Extreme Vulnerable Web Application. I'm not sure why it's not extremely vulnerable.
Yeah, right.
Anyway. So this is a PHP MySQL app specifically designed to basically have one of every different type of classic vulnerability in it.
Woo!
To help security enthusiasts learn about application security. So it has, an SQL injection because of an error in the code. It has another SQL injection that can be done blindly. It has, an OS command injection, an XPath injection, unrestricted file upload, reflected to cross-site scripting, stored cross-site scripting, etc. So that you can learn how all of these things work and how to use them.
That's really cool. That is a nice thing to be able to bang against. I like that.
Yeah. So it's kind of like, what was it, Metasploitable? That distro you could download that had, machine you could exploit. This is basically a web app with one of every known security vulnerability in it so that you can learn how those work.
Yeah, have fun. That sounds like a blast, actually. So you can find links to everything we just talked about over at JupiterBroadcasting.com. Look for episode 237 of the TechSNAP program, and then Allan has gone through and linked it all up. He just linked it all up, and it kind of goes in chronological order. So you just follow the order we covered it, and it shows up in the show notes. Now, don't forget, we are starting live next week at 11 a.m. Pacific, which is
4 p.m. Eastern, 2000 UTC.
JupiterBroadcasting.com/calendar to get that converted.
That's not what we'll be doing next week, right?
Oh, I don't know.
Next week will be 11 a.m., right?
That's what I said.
Oh, I just said the normal thing, which is not right then.
Oh, okay. Well,
so you said
11 a.m. Pacific.
Right. So that's 2 p.m. Eastern,
Okay.
1800 UTC.
See, here's what I legitimately do, and I even had to do this when I was on the road trip because I was going through time zones. Is I just check the calendar page. I just check the calendar page. You can just check the calendar page. JupiterBroadcasting.com/calendar. Pro tip: it has its own RSS feed. How about that? Also, did you know this show has an RSS feed? That's how podcasts work. Why don't you go subscribe to it? Get it every single week that we release one. I know, it's new information. Also, torrents are available and all that kind of stuff over at JupiterBroadcasting.com. And last but not least, we want your emails for next week. We got two shows to record. JupiterBroadcasting.com/contact. All right, everybody. Well, thank you so much for tuning in this week's episode of TechSNAP, and we'll see you right back here next week.